Hello and welcome to this instructional video. In this video we're going to go ahead and create our first operation or operations which are of the curve following type. So in front of you you have the part that you've been working with, the process file that you've been working with. At this point in time what you should have done is you should have loaded in a tooling catalog. There's a video that explains how to do this. So please refer to that if you haven't done that already. The other thing that's going to be important to do the curve follow is we're going to use the curve follow operation to do an engraving. So it's important that the geometry for engraving is present. Now we have that geometry already created in this demonstration part, but there's also a video too that shows you how to go about doing your own designs and so on. So please refer to that if you want to do your own engraving design. So what we're going to do is we're going to go under the prismatic part, which is the part here. Actually, I'm going to hide the stock temporarily. So right-click hide. And then we're going to go under the prismatic part into the body. And then if you go to the bottom of the tree, there is a sketch there called main view, which is hidden. Let's go ahead and unhide this. And I'm going to go into my top view, which is down here. And what you can see is a set of geometry, basically curves, lines, and arcs on a sketch that we're going to engrave on the flat bottom of the part, or actually the top of the part in the first setup. So let's clean up our tree. Let's compress our tree so that we don't have, so it's as small as possible. I'm going to also hide the auxiliary commands toolbar, which I used recently. So I'm going to go to toolbars and uncheck auxiliary commands. It's always a good idea to keep your toolbars as few as possible, so it's easy to find things, keeps your desktop clean. So what we're going to do is this is setup 1 that we're looking at right now. We're going to put a curve following operation into the manufacturing program that's present. So if we go over here to our tools and we move down the operations toolbar, actually I'm going to pull this off and just kind of have this up here, easier to see. So the curve following operation is the one that we're going to use to do engraving. So we're going to select on this, and then we're going to tell CATIA that we want to put that curve following operation into manufacturing program 1 in the first setup. And here's our definition window for defining the information for the curve follow operation. And if you look at the tree, you'll see that the plus button has appeared next to the manufacturing program. Inside that there's a tool change, which if you read this tells you that something needs to be changed, because it's saying that we're going to engrave with a face mill, which is not what we're going to do, but we will change that. And then if you click on the next plus sign, you eventually get to the curve follow operation that we're about to define. Okay, so the first step is if you recall, there was a video earlier on where I went through and described the process of defining an operation. So we're now going to follow that same process, but we're actually going to create an operation in doing so. So again, recall the first tab that you get to is the second tab in the set of 5. And this is to define the geometry. So for defining geometry here, we want to click on this line here, which represents the curve follow geometry that you need to select from the part. So let's click on this. The Edge Selection toolbar appears. We talk about this at some point in time. It probably isn't that important for what we're going to do today, but this allows you to speed up edge selection when you are doing very complicated curve follows. What we're going to do to speed things up is we're going to actually go back into the part, and we're going to actually select the entire sketch. Sometimes this is not possible depending on the complexity of the sketch. Sometimes it's necessary to select individual pieces of geometry on the sketch. But as you can see in this case, it looks like I can select everything that's on the sketch, the pattern as well as the letters in one shot. So let's click on the sketch. So you can see here that on the Edge Selection toolbar, a lot of tools that were previously grayed out and are available for you to work with to help you select the geometry. As I said, in this case, it looks like we can do everything in one selection, so these tools are probably not going to come into play for this particular operation. But we will revisit them for later operations. To end the edge selection, you can either hit the OK button on the toolbar, or if you go to the an empty part of the display, you can double click on the empty part of the display. So I'm going to quickly double click, and I'm now back to where I was before. If you were paying attention, you would have noticed that on this tab, this circle there was previously red, and of course the geometry that we picked, this line, was previously red. It's now green, and green is good. It tells you that you have specified what needs to be specified. Now, one of the things that needs to be determined for engraving is the depth of the engraving, and in this case here, what we're going to do is we're going to set this value here to an appropriate depth. More information will be given to you in class and in labs about what are good engraving depths. But for now, we're going to just simply use 10,000ths of an inch. So I'm going to double click on this, and in the axial offset, I'm going to type in 0.01. I made a mistake here. I should have typed in negative because it's an axial offset. We want to offset it in the negative direction. Now this is important because if you leave this as 0, your tool won't actually remove any material. If you make it positive, the tool will actually be moving above the surface where the engraving is supposed to be. So it's really critical to set this value here. Now this is a very simple definition window for geometry. That's all one really needs to do. There is the option to select fixturing. So if you feel that that's something you want to consider when you simulate, one can do that, but in this case, all the fixturing is below the surface, so it's not really something that's critical. The next step, once you do the second tab, is to move to the third tab, and the third tab is the geometry. Sorry, not the geometry, the cutting tool. And as I pointed out to you previously, when we inserted the operation, the tool change that was created used the incorrect tool, a face mill. So obviously that's incorrect for what we're trying to do here. What we want to do is we want to select the correct tool from the list of tools that we loaded in from the tooling catalog for this series of videos. We engrave typically with a center drill. There are specific tools one can get for engraving called gravers, but we use engraving, for engraving we use center drills. Now if you look at the tooling list, there are 3 center drills, a number 4 and number 2, and there's also a second number 4. The first number 4 is for etching or engraving. The second one is for drilling. So make sure you use the correct one because the speeds and feeds that are assigned to the tool are markedly different between engraving and drilling. Engraving, the feed rates are a lot faster. So we're going to select this number 4 center drill. Number 4 center drill is a larger center drill than the number 2 center drill. Number 2s are typically used for finer engraving. They are a lot more fragile though, so one has to be careful about breakage of those tools. So what we're going to do here is, since we're not defining a tool, we're actually going to select the tool that's already in the resource list. And we do that by going to this button here which says select a tool in the document. And we're going to go to the number 4 center drill for etching. And what you see here is that tool is selected. This window here shows all the parameters for the tool. So if you hold down the control key and your middle mouse button and move the mouse up and down, you can zoom. If you release the control key and hold on the middle mouse button, you can pan. So you can kind of see that geometric definition or dimensions of the cutting tool. You can also see these written out. If you click on the More button here, it shows you those same geometry parameters in these text fields. Also too, there are a number of other tabs up here that describe more information about the cutting tool. So technology would define the type of material. We use high-speed steel tools, the direction of rotation, typically right hand, and then most importantly, feeds and speeds. So these are the feeds and speeds that we assign to each cutting tool. which are the recommended speeds and feeds. Typically they would come from handbooks or from the cutting tool manufacturer. So and again, this helps you so that you don't have to necessarily go and look up these values. So that's the cutting tool, which is the third tab. The fourth tab over are the process parameters, the speeds and feeds for the operation. So typically what happens is the operation speeds and feeds get use the default cutting tool speeds and feeds. So if we go back to the cutting tool and look again at the speed and feed tab, we see that the spindle speed is running at 6,000 RPM or turns per minute. And then the feed rate per tooth is 2,000 inches per turn. So if we go to the fourth tab again, notice down here, the spindle output 6,000, so that matches the tool. And then the machining feed rate is calculated using the RPM, the number of flutes, and the number of the feed per turn. And in this case, it turns out to be 60 inches per minute. So for engraving, which is the tool moving in X and Y as it cuts the shape or the pattern, faster feed rates are acceptable. When you are using a center drill for drilling a hole, of course, 60 inches is way too fast, and that's the reason why we have a separate tool for center tool for drilling, which is very different. The other things that you have to bear in mind here with the operation that aren't copied in from the tool are the approach speed. So the approach speed is the speed at which the tool enters material, and then the retract. So how fast does the tool move away after the operation is completed? So in the case of an approach here, we can use 15 inches per minute. And then the retract rate can be really quick. In some cases, you can almost use the rapid rate. I'm going to use 60 inches per minute. So that's how fast the tool pulls away after the operation is done. Notice that you can uncheck these two check boxes here. And what these do is they allow you to override the operation, the speed and feed that are set from the tool. And this is useful if you reuse a tool, because sometimes you use a tool for multiple applications or multiple operations, and you may find that the speed and feed that you use for one operation is not exactly what you want to use for a second operation. So what you would do is uncheck this checkbox, and then you can override the, in this case, the feed rate, or down here, the spindle speed that was copied in from the cutting tool. So we'll stop there. In the next video, we'll move on to the fifth tab and then to the first tab to show you how to set approaches and also the strategy for doing a curve follow.